Hey everyone, today we're going to be going over a project that's called Juice Box Geometry. In this experiment, we're going to be working with volume, measuring, average or mean, also working with graphs and tables, and interpreting the data. Okay, so for juice box geometry, this is going to be our problem. Although juice boxes come in containers of the same size, the amount of juice included varies from brand to brand. If we were to take multiple brands and compare the volume of the juice inside the container, which brand gives the most juice compared to its size? So for our hypothesis, I'm going to say that the juice boxes with the greatest volume will also contain the greatest volume of juice. It's only logical, but let's test it out and see for sure. So for our experiment, each juice box will be measured to the nearest centimeter. Using the box's length, width, and height, the student can determine the volume of the juice box. Making a chart, they can compare the volumes of each kind of juice. Now they must compare the volumes of each juice content to the available volume. To find an average juice content volume, the student will pour out 5 juices into a measuring container, find the volume of the 5 juice boxes, and divide by 5. Each juice box will give a different content volume to be added to the chart. Now we can find the difference between the available volume and the juice contents volume. Then the student will be able to compare and see if the hypothesis is correct. So I got some different juices. I got Yoo-Hoo, Mott's apple juice, Minute Maid apple juice, Hi-C orange, and Juicy Juice. I will be referring to these as brown, blue, green, orange, and red. So to measure our volume, we're going to measure the length, the width, and the height of each box and put it into our data chart. For brown, we have 218.88 milliliters. Blue has 218.88 milliliters as well. Green has 191.52 milliliters. Orange has 189.70 milliliters. And finally, red has 132.10 milliliters. Now that we have our box volume, we need to measure our juice volumes. Each juice is poured in 5 different times, and then I divided the volume by 5 for each one. For our brown, we had 190 milliliters. Blue gave us 200 milliliters. Green gave us 175 milliliters. Orange gave us 174 milliliters, and red gave us 120 milliliters. Now that we have our volumes, we can add it to our chart. And I apologize for the side pictures. And we can make a table. Using the table, we can come up with the difference between the two volumes, and then we can find our percent difference. And the percent difference will give us how much air per volume is in the boxes. This is the original order of the juices compared to the size of the box. This is order compared to how much juice is inside. For our results, to test the hypothesis, we have compared the brown and blue juice brands and the green and orange juice brands because these juice brands had similar box volumes. The first group did not follow the hypothesis. The second group did follow the hypothesis, but only slightly. Taking the experiment a step further and comparing the percent difference shows the largest box volume contains the least percent volume of juice. The second smallest percent volume of juice had ironically the smallest box volume. These results disprove our hypothesis. Hi-C orange contained the most juice contents per box volume and was also the second smallest box volume. More research will be needed to compare the correlation between the juice brand volumes. For our conclusion, these seems to be only a small correlation between the volume of the juice box and the volume of the juice inside. A big box may have a small volume, but a small box cannot match the volume based on its size. Further testing should find more brands with similar volumes to compare their contents. So I hope you enjoyed seeing my project. This is something I think a lot of kids will enjoy, so good luck!